Each day, we take in lots of information through our senses, then figure out its importance, and decide how to respond to it.
All these pieces of information, things we can see, hear, touch, count, or measure, we call data.
Figuring out the cause, the significance, or the results is interpretation.
The scientific process is all about collecting data and interpreting data.
At school one morning, the 8 o'clock bell rings and you notice that your best friend isn't there. You start to wonder if maybe she's sick, broken down by the side of the road, or just stuck across the railroad tracks while a train goes by. You noticed something that was important to you and you started asking questions. Out of concern for your best friend, your questions focused on what might have caused her to be late.
Another person might be concerned about the consequences of her being tardy. Will she get in trouble for being late? Still another person might think of ways to help her avoid being late in the future.
Data can be important to different people for different reasons.
Not every question needs to be or can be answered by experimenting. Sometimes we can just ask.
Has anyone seen Morgan?
Yeah, I saw her car by the railroad tracks this morning as the gate was coming down. She should be here in a few minutes.
Sure enough, she arrived shortly afterwards.
By asking for information, the principal could easily see whether her tardy will result in any consequences.
Would you please pull up Morgan's attendance record?
All right.
Morgan has hardly ever been late, so no consequence is necessary.
We can't always get the answers to our questions by just asking. Sometimes we need to experiment, like when you want to figure out how to prevent being late to school in the future.
Science is really good at answering questions about what will happen if students put this metal ring on this coil of wire and run an electrical current through it. Turn the spinning wheel this way or that way. Shoot a ping pong ball through this pipe just using air pressure.
This is called empirical science.
The results happen right in front of us, and we can even repeat them to see if the same things happen next time.
If the experiments are designed well and are repeatable, lots of data can be gathered and we can be pretty sure about our conclusions.
Because of this kind of experimentation, the scientific process has given us things like cell phones, skyscrapers that can withstand earthquakes, spacecraft exploring outer space, organ transplants, and so much more.
But the scientific process isn't always as simple as it might seem.
Sometimes, we're too quick to accept an explanation for something before we check it out thoroughly.
Glad you made it. Jamie said she saw your car stuck at the railroad tracks this morning.
It probably was my car, but I wasn't in it. I stayed at my aunt's house last night and she drove me to school. We were late because her car wouldn't start.
And sometimes, we aren't quick enough to accept a new explanation.
Remember Spallanzani and his bats? No one believed at first that bats use their ears to navigate. A guy named Cuvier, who was a more well-known scientist, believed that bats use a specialized sense of touch to navigate, and because he was more well-known, most people believed him.
Scientists don't always get things right the first time, and they have to try over and over again before they actually figure things out.
Scientists used to believe that the Earth was the center of the universe.
It took many years before we figured out that our Earth orbits the sun instead.
During the Middle Ages, people believed that living things arose spontaneously from non-living things.
What do you mean?
Well, they noticed that mice would appear on a pile of rags in a corner, and they thought that the mice came from the rags.
Seriously?
When they saw maggots appear on meat without having come from anywhere, they thought that the meat produced the maggots.
Wow.
This is called spontaneous generation. It took a couple hundred years for scientists to finally prove that the mice did not materialize from the rags, and the maggots did not come from the meat.
Those are some examples of conclusions that people, even scientists, had accepted for centuries that turned out to be wrong.
So it's not really unusual for scientists to change their mind about things after more data is gathered.
Usually, the scientists of past centuries were following the scientific method just as well as we do today. They were no less scientific, they just hadn't gathered as much data yet.
Over time, scientists can work together to identify and replace incorrect theories. As they share their conclusions with each other, they can help each other figure out where the mistakes are and how to find more correct answers.
Another time when science isn't as simple as we might think is when we're trying to figure out what might have caused something to happen in the past.
When something happens right in front of us, it's pretty easy to figure out what happened. But often in science, that is not the case.
Think about a crime you heard about on the news. Now, if there were no witnesses or no one willing to tell what they saw, police officers and detectives would have to piece together what happened by finding clues. Often, they can figure out what happened days, weeks, even months ago.
Trying to find out about something that happened 100 years ago is even harder, and it is only possible if some kind of record has been left for you to see.
The further back in time you go, the harder it is to find answers.
For hundreds of years, scientists have been trying to answer questions like, where did the universe come from? Or where did life come from?
This is an example of historical science, and it's not the same as empirical science.
Remember that in empirical science, results are observable and experiments are repeatable.
We can look for evidence about how the universe began, but since it wasn't observable and definitely not repeatable, we're limited to how much we can learn about it using the scientific process.
Let's review what we've learned.
In the scientific process, we try and find answers to questions by gathering data and interpreting data.
Sometimes we ask about causes, and sometimes we ask about effects.
Science isn't always as simple as we might think it is, and sometimes scientists are wrong, and they have to change their mind about things.
Empirical science is really good at creating observable, repeatable experiments that can answer questions about things that happen now.
But the scientific process is very limited in its ability to answer questions of historical science like, where did the universe come from?